Wouldn't it be cool to have an eternal source of energy to power our world? Such a machine would be called a perpetuum mobile. That's Latin for constant movement. Once you set this machine in motion, it would continue working forever until someone or something stopped it. Sounds ideal, but for now, perpetual motion is only a hypothesis. That doesn't mean that during the course of history, people haven't tried to construct one. In 1618, an English physicist, Robert Fludd, proposed something called a closed-cycle water mill that never stops working, if you like it better. The Englishman's idea was simple. Water would fall from a reservoir onto a mill wheel. The energy of the spinning mill would then be used to return the water back to the reservoir, and the water would go down again. You get the concept. Sounds good on paper, but this kind of machine wouldn't work. The energy of the falling water would never be greater than the energy needed to get the water up to the reservoir. The English physicist based the idea on Archimedes' screw. This was a machine envisioned by the famous Greek inventor Archimedes for Syracuse, Sicily. It was basically a long pipe that could have been used for removing water from a ship's hull. But one look at the design reveals that the contraption would have a lever at the top. A person would have to turn it to get the water moving from below. So it was hardly a perpetual mobile. That's why the proposed water mill would never work. There is simply no extra energy needed to power the machine forever. Moving on from the power of water to the power of the vacuum. This is a space with no matter inside. In 1873, Sir William Crookes discovered a perpetual motion machine that used the vacuum, Crookes' radiometer. He was a British chemist and physicist. The man was a pioneer of vacuum tube technology. His device resembled a tiny windmill trapped in a glass light bulb. Inside, there is no air, just a vacuum. When you shine light on the vanes, they start to spin. The stronger the light, the faster the spinning. In bright sunlight, the windmill can spin at several thousand rotations per minute. Crookes never intended to construct this device. He initially wanted to precisely measure weight. The scientist used the vacuum to minimize any interference from air currents. An odd thing happened. Every time sunlight shone directly on the measuring instrument, the readings changed. At first, the man was puzzled. Crookes didn't know why this happened. It took scientists a full 6 years to explain the phenomenon. It had to do with the color of the veins. You know how your parents taught you not to wear a black shirt on a hot summer day? They were right. Black attracts heat, but it also blocks sunlight. One side of the veins was colored black and the other silver. The darker side absorbed more heat and created just enough momentum for the veins to start spinning. It's like the black side is trying to move away from sunlight. This only happens in a vacuum. If there was air inside, the veins couldn't move because of friction. And the amount of energy created by the rotation is minuscule. It wouldn't be able to generate electricity. The device simply converts thermal energy into mechanical energy and needs light to work. Sunlight comes to us free of charge, but the sun doesn't shine 24/7. So Crookes' radiometer isn't a true perpetual motion device. It's more of a neat science experiment you can try out at home. A clock in New Zealand came much closer to a true perpetuum mobile, Beverley clock. It sits in the hall of the Department of Physics at a university in Dunedin. Arthur Beverley, a local watchmaker, constructed it in 1864. The man wound it on the day he made the clock, and it has been running ever since. How is it possible that a mechanical clock has been working for over a century and a half? The answer lies inside the device. It contains an airtight box that expands and contracts as the outside temperature changes. This motion pushes on a diaphragm that lifts the weights that wind the clock. This atmospheric clock wasn't 100% efficient, though. The clock doesn't require a person to wind it, but technicians have to stop it for repairs and cleaning. It has had several mechanical failures in the past. The design of the time-measuring device means that if air temperature and atmospheric pressure remain constant during the day, it will stop. When the temperature during the day doesn't change by at least 6 degrees Fahrenheit, the clock will lose time. That's why it isn't a true perpetual motion machine. But its mechanism still functions after all that time. This makes the Beverley clock the closest someone came to constructing a perpetuum mobile. Another attempt was the Oxford electric bell. It's not a machine like other attempts on our list, but a battery. It arrived at Oxford University, England in 1840. Researchers believe it was a decade and a half old at that time. The battery propels a hanging metal ball that swings between two small bells. It has been ringing for almost 2 centuries now, an impressive feat for a primitive form of an electric battery. Its alternative name is the Clarendon dry pile. This is because the battery is made from alternating discs of zinc, silver, sulfur, and other materials. That's the pile in the name. When materials are stacked up like this, they generate low electric currents. Giuseppe Zamboni, an Italian physicist, was the first to make these dry piles at the beginning of the 19th century. The man's last name sounds familiar to hockey fans. But the inventor of the Zamboni machine, Frank Zamboni, lived more than a century after his Italian namesake. Back in Oxford, if the bells have been ringing for so long, have scientists received complaints from neighbors? Not really, because the device is barely audible. Just in case, they have placed the contraption behind 2 walls of glass. The Oxford electric bell is the longest-running science experiment in history. That's why researchers have resisted the temptation to take it apart. They will patiently wait until the battery runs out, or the mechanism breaks down because of old age. Whatever happens first. For now, the air or mystery around the Oxford electric bell remains. At least one thing is clear. Every single attempt at building a perpetuum mobile is destined to fail because they violate the laws of physics. The first and second laws of thermodynamics, to be precise. The law of energy conservation, the first law of thermodynamics, states that energy is always conserved. It cannot be created, nor can it be destroyed. It just changes form. For instance, when you turn on the light bulb converts electric energy into thermal heat energy and, more importantly, light energy. For a machine to run endlessly, the applied energy needs to stay in the machine without any losses. Sounds plausible in theory, but in practice, it's impossible. If a machine has rubbing parts, then friction is created, and friction generates heat. One example is when you rub the palms of your hands to stay warm on a cold day. But this isn't good news for perpetual motion. Heat is lost energy, so the machine would never be able to operate at 100% efficiency or greater. This is the second law of thermodynamics. It reveals that every time energy is transferred or transformed, more and more of it is lost. That's why every attempt at constructing a perpetuum mobile is flawed from the very start. In one word, a perpetuum mobile is impossible to make. The U.S. Patent and Trademark Office is very well aware of this. That is why you first need to have a working prototype before applying for a patent of a perpetual motion machine. In every generation, there was an inventor who thought they had fooled the laws of thermodynamics, and the people at the patent office simply got tired of rejecting their designs one after another.